Hey there, C# friends. My name's Matthew. I'm the C# artisan, and this is the first video in my new series on nullable reference types. Now, if you've been doing C# for a while, you know the language has evolved a lot. A lot of amazing features have been added. Think about extension methods, tasks, lambda expressions, anonymous types, auto properties, and more recently, things like pattern matching and string interpolation. The list goes on. C# has changed a lot, and these new features have really made it better. But in 2019, with C#8, Microsoft introduced a C# language feature that hasn't been so universally loved. In fact, it's kind of generated a lot of confusion and debate, and in some cases, outright dissent. I'm talking about nullable reference types. In this series of videos, I really want to dig into this language feature and help you as a C# programmer not only understand what it does, but make an informed choice about if and how you want to use it. So let's start by asking the obvious question. What is it for? What do nullable reference types do? What is the purpose of this feature? That's what we'll talk about today in this video. What is it for? What do they do? So in a nutshell, the purpose of nullable reference types is to prevent null reference exceptions. You probably know what those are, but let's take a look. Let's write some code where we generate a null reference exception so you can see exactly how they come about, and then let's make our code safer so that we don't get null reference exceptions. So I've got a little test project for us, and let's start by adding a class to it. So we'll add a class, and I'm going to call this class Polygon, and I'm just going to give our Polygon class one property. But I'm also going to add a little static function to our polygon. So public static void hello triangle, which takes a polygon as the input. And the way hello triangle works is it says if p.sides equals 3 equals 3, then console.writeLine hello triangle, else not a triangle. So there's our little static function. Now back in our program, we can create a polygon. And we can set its sides to 3. And then we can call polygon hello triangle, passing in our polygon. And let's see what happens. Let's go ahead and run this code. Press enter to begin. Hello triangle works. So here's the problem. What if polygon P is null? If we pass a null to this, we're going to get a null reference exception right here. Because when we attempt to dereference the sides property, if P is null, we can't do it, and it's going to blow up. So let's go ahead and make that happen. So instead of calling hello triangle on our polygon, let's pass null to that function. And let's see what happens now. We'll press enter to begin, and there we get it. Null reference exception, object reference not set to an instance of an object. And it's right there where we call p.sides. So how can we fix this? Programmers learn very early to write defensive code like this. We can say if p not equal to null and p.sides is 3, then hello triangle. So now when we run our demo, it says not a triangle. We made it null safe. There's actually a little bit of a quicker way you can do this. You can use the null conditional operator, which is this question mark, which basically says only dereference P if it's not null. So this is also safe. It should have the same effect. And it's not a triangle. And just for completeness, we can go ahead and put it back so that it works to make sure our code works in both cases. And it's a triangle. So there you go. That is a null reference exception and how you prevent it. Something we all probably learn very early in our coding careers. One thing I want to point out is that in C#, strings are also nullable. They are reference types. So to illustrate that one, why don't we add a static function here that returns a string, and let's call it replace ampersands. And it takes a string as the input. And we will return s.replace, and we'll look for all instances of this and replace it with that. And now we can test it here. We can say string message equals hello Phineas and Ferb. Whoops. And then message equals replace ampersands. We'll replace that. And then console write line message. So this should change this in the way we expect. Let's go ahead and run our test. And there we go. We've got Phineas and Ferb with the ampersand replaced with the word and. But once again, what happens if we pass null to that function? And it's going to blow up because s.replace, you can't dereference s if it's null when you call replace. So we'll let it blow up so we can see it happen. And same thing, system.null reference exception. Okay, so how do we fix this one? And we could do the same thing. We could say if string.is null or empty, and then we could say, I don't know, return whoops, just so that we have a return, else, and then we can return our replace. So now if we pass null in, we should just get a message that says whoops, and we do. But if we go ahead and we pass our correct message back in, it should still work. Let's prove it. Okay, it all works. And as we saw with our hello triangle function, there is a shorthand way to do this, where we can simply say return s colon dot or s conditional replace. This will still be null, which is kind of a problem. So we can just coalesce that and say whoops. So this is our null coalescing operator. We'll return the first non-null value. So if this was non-null, that's what you get. Otherwise, if that was still null, we'll go ahead and get that. So this should work. Here's our case where it has a valid input. And we can go back and put it back and have it return an invalid input. Whoops. Okay, so those are null reference exceptions. They happen when you dereference a null object. You prevent them by checking first for nullability. And like I said, most of us learn to do this pretty early, but the reality is there is still code out there, and maybe you've written some, that isn't null safe, that doesn't contain these checks. And those become a problem. They can potentially blow up at runtime. Maybe when you wrote the code, it was safe to assume that it would always be not null, but then something changed and later it became null, and then you've got these exceptions. So wouldn't it be nice if the C# compiler could warn us could give us some compiler warnings that say, hey, this code is potentially not null safe. So that is exactly what Nullable Reference Types tries to do. That is the purpose of the feature, is to enable some compiler warnings that point out this kind of unsafe code. But it's a little complicated in terms of how it actually does it. So that's what we'll look at next, which is what does the compiler really need from you as the programmer in order to give you those warnings. But that is what it does. It's trying to give you warnings of potentially null, unsafe code. That's what it does. Hey there, C# friends. Are you enjoying these videos and finding them helpful? I hope so. And if you are, please go ahead and like the video on YouTube. If you haven't already, please subscribe to my channel and feel free to leave a comment. I would love to hear from you.